Good morning, and we'll be talking about dangling pointer today as it is something important to know and watch out when you're writing programs because dangling pointers can cause seg faults when you're compiling, and it can also lead to some security vulnerabilities in software and also unexpected crashes. So what exactly is dangling pointers? So they are a pointer that points to a memory location that has been allocated or freed, leading to undefined behaviors when program attempts to access or modify the data at that location. So in a simpler words, it's basically that the object pointer points to is no longer valid, but we still have the memory address linking to it. So we should not have it. And as an example here, let's look at this function called generate that returns an integer pointer. And inside we have an integer array called nums. So this is an array, and it's called nums that have 5 elements. So it's the number of elements. And this is the array, and this is a local array on the stack. And now we have a main function that declares an integer pointer called ARR that is equal to what genArray function returns. And we say that ARR is a dangling pointer. So why so? Let's look at the stack frames for these functions. So this is the stack, and this is the main. And let's say this is genArray for generating arrays. And one of this is a stack frame. So here we have a pointer called ARR in main that points to whatever that's being returned from generate. The generate returns nums. And nums, what is num? Nums is an array. So array that has 5 elements of 1, 2, 3, 4, 5. And we have previously learned that an array that usually is a pointer that points to the first element of the array, so which is like the first one. So it's where 1 is located. And let's say this 1 has a memory address of 0x8000, then nums is equal to 0x8000 because it points to the first element of that array. So what is being returned to the pointer ARR will be 0x8000. And after the function is being run, the function memory will be freed. So this whole thing will be crossed out and this will be garbage. So everything is discarded, and now ARR points to the memory address of 0x8000, and now it's pointing over somewhere over here, and it's garbage already. Therefore, the object the pointer points to no longer is valid. Therefore, we have a dangling pointer, which is ARR. And how do we fix it? Basically, it's dynamically allocating the memory. So how do we dynamically allocate the memory? Basically using malloc. So in this new function we see that the generate, we have an integer code equal to 5, which is the same as the number of elements. And how much memory do we want to malloc? It's the number of elements times the size of int. So basically have 5 times the size of int, which is usually 4 bytes. So it is equal to 20 bytes. So this is the exact number of bytes we will malloc to store this array. And this is assigned to an integer pointer called nums. So if we take a look at how this is being done on the stack, similarly, we have the stack, we have main, and we have genArray. So something happened differently in genArray is that we have this nums, and now it's a pointer. And it points to something we malloc. So what's malloc is being stored on the heap. So on the heap, now we have something that's 20 bytes. And there's 5 of them. Each one of them is 4 bytes because it's an int. And let's say this whole array has the memory address of 0x1234. So now the pointer nums is equal to 0x1234 as it points to the memory address on the heap. And now let's look at the main. Main, now we have a similar pointer ARR that points to what is being returned from the generate. And we see here that it returns nums. So this is basically what nums is. So nums is 0x1234. So the memory address of 0x1234 is being returned. And now we finish running generate. So this whole thing, this stack, the memory is freed and it's garbage now. But now the pointer ARR is 0x1234. So it points to the heap, which has the array that's stored in the memory address of 0x1234. So now it's pointing to something valid. So we solve the dangling pointer we have in the previous function. So you have to free whatever that you mallocked after you use it. And why do we do that? Is because we want to prevent memory leaks. Because the program consumes more and more memory as it runs over time, then it's just gonna pile up and eventually becoming full, and you have no memory to use anymore. And then we have to assign the ARR to null. This is also to prevent dangling pointers.